Hey guys, welcome back to another tutorial on fuzzy sets. So in this program we're going to learn how to compute the mth power of a fuzzy set or how to find the exponential value of a fuzzy set. So here we have a fuzzy set, or I would say in this case it's a dictionary, and how to calculate that exponential value. Right here the exponential value we are giving as 2, which means the square of the membership value, and it gives us the result corresponding to that element, right? And I would recommend that you would see the previous videos where I had explained the architecture of this program and what we have inside the main method and how we have called the objects, how we have used the objects, and why we're using self keyword inside the class. So I would recommend you watch them before you come to this. It'll be easier for you to understand. So I'll just skim through this entire program before we come to the main part, which is find exponent method. Currently it's commented out here, so before we come to this method I'll just skim through uh, the code here. So we have a number of elements here, and we created an object. After creating this object, what happens is this default constructor is called invoked, right? And on invoking this constructor, fuzzy dictionary is created, which is an empty dictionary. And after this, on creating the object, we're going to use the object to call the create fuzzy method, create fuzzy dictionary, which is this method right here inside the class exponentiation, and it has a parameter self, and we call this a method about the number of times as we have entered as the number of elements, right? So inside this method we have two infinite loops, and each infinite loop is responsible for entering the element and membership value. So if we enter the same element, it gives us this statement, this printout, that element already exists to enter a new one. So if we enter a new one, it breaks through the loop and re-enters or enters into a new loop, that is the membership value. And on entering a membership value, it has to fulfill a condition between 0 to 1, upon which it updates the element with the particular membership value that we entered into the fuzzy dictionary. And on fulfilling this condition, it breaks through the loop and we move out, coming back to the main method. On not being able to fulfill, it shows us invalid value, try again, right? So I'll just close this and we'll come to the method which says find underscore exponent. So I'll just uncomment it out, and so we were here. Now we print the set, the fuzzy dictionary that we have entered, and we call it using the object, and we have an exponent here which is of type float. So what happens in exponent? We are entering the exponential value. So the user, or I will be entering an exponential value, say 2, which means the square of a membership value, and I will put that value, pass that value in the find exponent method. So I will call this find exponent method using the object, and I'll whatever result I'll get from this method, which is returning a dictionary, right, into result, and that I'll be printing out. So there are many ways to approach the finding the exponent right here. So since we have passed the exponent right here, we are receiving it here as type float, right? And we have initialized the result of type dictionary to an empty dictionary, and we are returning the result which is of type dictionary. And inside this method we have a for loop that runs for every element and membership value, that is key and value, in the fuzzy dictionary dot items method. So item methods returns a set like object providing a view on the dictionary items, right? So it gives us the key and value of items inside items method. So basically it gives us access to the key and value. So the first approach that I will be coming with is using the direct operator or double star symbol. So how do we do this? We take the result corresponding to that element, right? And we have to assign something to it. So what we assign is the membership to the power of the exponent value. Now I have access to the exponent here, So what I'll do is membership double star the direct operator into its exponent, right? So I'll just compute this and I'll see what I'll get. Enter the number of elements, say 2a 0.5 will give us 0.25 and b say 0.2. Exponent value, say I'll give it a square, right? So okay, this is giving us a very large number, so what I'll do is I'll take this and put it inside a formatted string, and I'll take the exponent and turn it to a decimal of nearest two places. So I'll just check 2a 0.2 b 0.5, right? Is giving us to the nearest two digits. So like that, there is another way, that is using the power function that is given to us by the built-in function of Python, right? So result element equals the power function of what, the membership value, right, to the power of the exponent. This is another way of doing it, right? Just check it out. A 0.2 b 0.5 exponential value 2, right? So since I didn't put this into a formatted string, that's the reason why it's giving us a large number. So we're just going to overlook that and move on to the next approach. Another way would be to use the maths module, right? So we have to import math for this. Yep, right here, import math, and we have result corresponding to that element. We have math.pow, the membership value, and what is the syntax, sugar? Return x to y. So we have, okay, it's comma, okay, so we just put a comma right here. So membership and provide the exponent, right? This is another way of doing it. Number of elements 2, say a is 0.2, b, I'm giving all the same values, so really doesn't matter. 6 to the power of 2 is 36, so 0.36, right, gives us the right order. So I'll just clear this out, kill the terminal, and proceed to the next. There is another way. So far we've learned that in this math.power, even if inputs are or integers, what it gives us is a float, right? So even if membership value is an integer value and the exponent is also an integer value, then math.power function or method will always give us a float value. So it uses a C-level implementation for math libraries, right? So I think we have skipped to see that part. No, it doesn't provide it in this module, but it's best to avoid unless you explicitly need the float coercion. So another way of proceeding with this is the functional style, using maps and lambdas and dictionaries, like converting into a dictionary finally. So how we proceed is we take result, right, and we want to assign we want to first map through, say, lambda, which is a anonymous function in Python which is used to calculate what's inside the tuple. So we need a tuple here, so take item, and inside this tuple we have item 0, which we'll refer to a right here, right? Item 0 is a, comma, item one which will refer to the membership value. Now with this membership value, what I'm going to do is use the same default operator right here into the exponent, right? Comma, what we are going to do in the next line is we have to say from which dictionary are we referring to, dot fuzzy dictionary dot items. I think that is the syntactic sugar, right? And therefore map this entire thing finally. So after we do this, the result that we'll get will be in the form of a tuple, right? So what we need to do is wrap this up inside a map, okay, like that. So this is one way of doing it. So we'll just check if it gives us what it needs to give. Say 2a is 0.2, b is 0.6, exponential value say 2, right? So it does give us the value, okay. So this is the fourth approach, and that is the membership val into, okay, exponent, right, to the power of exponent, right, this part. Okay, so and this dictionary is basically to convert everything. It reconstructs the entire dictionary back to its normal state. And the fifth, and I think I would say that this is the last. There are other ways also, but then another approach which I would say is dictionary comprehension. In other words, the syntactic sugar looks somewhat like this. Result equals inside a dictionary, say element membership into its exponent to the power of its exponent. That's how we should enunciate. For element, do we have access to element? Yes, we do. Element membership value, right, in self dot fuzzy dictionary dot items, right? This is one way of doing it, but I think this will give us this another large figure. So to avoid that, I'll just put a round method, right? Gives supports round 1, round 2. Okay, so 1 second. You cannot see. So how do we access? Okay. Supports round 1. Okay. What do we do with this? We take exponent around nearest to I think the second n digits, right? Nearest to how many digits? So we take 2, right? So this is another way of doing it, another approach, and we just check it out. Number of elements 2, enter a 0.7, which will give us 0.49 I think, and 0.2, exponential value 2, right? So these are the different approaches that I can come up with. So that's how you compute the mth power of fuzzy set in Python, transforming each membership value using exponentiation. So the key takeaway is not just the code, but how the exponent reshapes the set, making it sharper or more diffuse. If you understand that, you're thinking in terms of fuzzy logic, not just the syntax. So in the next video, we'll build on this and explore more operations that actually matter in real-world fuzzy systems. So stay tuned. See you on the next one.